To sum up this particular chapter, we started off with a basic definition as to what is a set and what are the characteristics of a set. Correct? So whenever we have a defined set of elements or defined elements, that is what we call as a set. Then we discussed about different types of sets, correct? Empty set, a universal set, subset, and then we have finite and infinite sets. Then finally, we discussed about different types of operations on sets, right? Now, in between, we also understood about what is a Venn diagram. So, Venn diagram, you have combinations of circles and a rectangle, where each set is represented in a circle, and a universal set is generally the outside part, correct? Now, the next part is the operation, where we discussed about union, intersection, and difference of a set. Now, whenever we talk about union of a set, it is where multiple sets are joined in the sense the elements are taken together. That is basically union of sets. Then whenever we talk about intersection, it is when the common elements are taken out, and that is basically intersection, right? Then we have difference of sets. Difference in the sense what? The elements which are present in one set alone or only. That is basically difference of the sets, right? And each of them can be represented in a unique way in the Venn diagram, like what you're seeing on the screen here. This is the individual way of representing a union, intersection, and difference, right? Then we have the complement of sets. Complement is what? Whenever we have a set and a universal set, the elements which do not belong to the set, but they belong to the universal set. That is basically the complement of a particular set. Then we have certain properties of complement. Along with the union and intersection also, we have properties for the complement. Of all the properties, one property is extremely important, which is the De Morgan's law. The De Morgan's law basically states A union B whole complement is A complement, intersection B complement. Or if you have A intersection B whole complement, it is A complement union B complement. This is De Morgan's law. Now, after that, we discussed one or two formulas actually. Now, more like a property, I would say it's a formula which can be used in multiple cases. The first one was for two sets, which gives a relation between union, the sets, and the intersection. Like n of A union B is n of A plus n of B minus n of A intersection B. Then we did the same thing. We extended that into three sets. So n of A union B union C becomes n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. Right? Now, all these formulas, all these properties, the range and different types of sets, this is the entire chapter of sets.